Welcome, focused learners, to today's Explainer. I am absolutely thrilled to have you here today because we're taking a literal launch sequence journey. We're looking at how these massive, towering structures manage to just completely break free of Earth's gravity and travel into the great unknown. Yep, we're talking about rocket science. So, grab your notepads because we're going to build this understanding from the ground up using clear, structured concepts to get us straight to orbit.
You know, we hear the idiom all the time, right? Hey, don't worry, it isn't rocket science. People use it whenever they want to say a task shouldn't be too hard to grasp. But ironically, that phrase makes actual rocket science seem like this incredibly intimidating, insurmountable wall of knowledge. Well, I'm here to playfully challenge that idea. While the advanced math is for sure complex, the fundamental concepts, the actual why and how of a rocket leaving the pad, aren't entirely accessible. We're going to break this formidable topic down into highly manageable, highly logical pieces.
Okay, so here's our pre-flight checklist. 1. Demystifying rocket science. 2. The laws of launch. 3. Understanding jet propulsion. 4. The multi-stage flight process. And 5. Fast facts and orbit. Let's initiate the sequence.
Section 1. Demystifying rocket science. Grounding in the basics.
Section 2. The laws of launch. Newton's mandates.
Okay, let's dive right into this. To understand how we get high into the vastness of space, we really have to start by getting firmly grounded. Newton's first law, inertia, is beautifully simple, even when we're talking about a towering spacecraft. Think about it. Before the countdown finishes, a massive rocket stands perfectly still, locked to the pad. It will not budge a single millimeter until an immense external force is applied. But once that force hits, and the rocket is set into motion, it becomes an unstoppable object that just wants to keep moving. It's a fundamental game of physical forces.
Now, building on that idea of inertia, the second law dictates that the immense mass of orbital rockets requires a proportional, massive amount of force just to budge. A lightweight projectile, well, that needs very little fuel. But a fully loaded spacecraft needs immense, violent energy to conquer gravity. And this is absolutely crucial. The third law provides that energy. Forcefully exhausting hot gas backward creates the equal and opposite reaction that pushes the payload forward and ultimately upward toward the sky.
Section 3. Understanding jet propulsion. The ignition sequence.
So, propellant is the fuel, which can be solid or liquid, stored safely inside the rocket's chamber. But fuel alone doesn't do the job, right? To launch the rocket upward at those incredibly high speeds, this stored fuel must be mixed with oxygen gas and burned. When this ignition happens, hot gas violently shoots out from the bottom end of the rocket. This creates a tremendous amount of momentum. In rocket science, we call this upward push thrust, and this entire explosive, thrust-generating mechanism is known as jet propulsion.
So what does this all mean? We've got our fire, we've got our thrust, we're pushing against gravity, but we run headfirst into a massive engineering wall. Is the thrust produced simply enough to launch the rocket all the way? You see, because heavy objects need more force. To get a massive payload into space, you need tons of fuel. But fuel itself is incredibly heavy. So to lift the heavy fuel, you need more fuel, which adds more weight. It's kind of like a giant, frustrating puzzle. Sometimes that initial thrust is simply not enough to overcome the massive amount of dead weight required just to get off the pad.
Section 4. The multi-stage flight process. Shedding weight for acceleration.
So how do engineers actually overcome this fundamental problem? The answer is an absolutely brilliant engineering hack. If heavy things are hard to push, the solution is simple but revolutionary. Stop being heavy. The heavily choreographed dance of a multi-stage flight process is an absolute engineering marvel, and it's our main focus today. Let's walk through it. Stage 1 begins when the solid propellant boosters ignite. This first stage carries a tremendous responsibility, lifting the fully fueled behemoth off the ground, pushing it high into space, and reaching unbelievable speeds of up to 28,000 kilometers per hour. Then, stage 2 is where the real magic happens. Once those massive side boosters consume all their solid fuel, they just become giant, useless metal tubes. They're literal dead weight. So the rocket cleanly detaches them, dropping that mass entirely. Next, stage 3 kicks in with the main engine. Because it's now pushing significantly less mass, it can easily accelerate the much lighter rocket further into the upper atmosphere. And in a continuous cycle of shedding, once that main engine consumes its fuel, well, it detaches too. This systematic shedding process allows the remaining structure to achieve greater and greater acceleration until stage 4, where, stripped down to just the absolute essentials, the payload is seamlessly sent right into its desired orbit.
But this leaves us with a very practical question, right? What is the aftermath of all this shedding?
When these separated parts detach after consuming their fuel, they don't just magically disappear. Usually, these massive, empty components either fall harmlessly off into the vast oceans below, or they're subjected to the intense friction of re-entry and are entirely burnt up into the atmosphere. While it might sound kind of counterintuitive to purposefully tear apart your own vehicle mid-flight, this brilliant, calculated strategy of shedding empty weight is the only physical way to ensure the final payload safely achieves orbit. It literally sacrifices the vehicle to save the mission.
Section 5. Fast Facts and Orbit. Reaching the Climax.
Okay, consider the year 1180. We tend to think of rocket science as this ultra-modern 20th century marvel of the space race, don't we? But actually, the very first rocket was invented around the year 1180 in China. Now, they weren't sending satellites to orbit back then. These early rockets utilized basic solid propellants and were mainly used for dramatic weapons and spectacular fireworks. But the core physics, that third law of action and reaction we talked about, was exactly the same.
Now, contrast that ancient history with a single digit, 7. Today, to successfully burst through the immense gravity of the Earth and stay in space, a modern multi-stage rocket needs to travel at a staggering speed of 7 miles per second. Just let that sink in for a second. 7 miles every single second. Now that is some serious speed, completely unachievable without that multi-stage shedding process we just explored.
Which leaves us here, looking up at the stars. We've demystified the science. We know that immense mass requires immense force, that escaping gravity requires volatile propellants, and that shedding weight in sequential stages is the ultimate key to conquering the sky. But understanding the how only leads to a much bigger why. As our multi-stage rockets get more efficient, and our understanding of these foundational physics deepens, what new frontiers will this technology help us discover next in our search for a brighter future? Will we shed stages on our way to Mars? Or maybe even further? The launch pad is ready. It's up to us to see where we go next. Thank you for joining me on this explainer, focus learners. Stay curious and keep looking up.